Good evening, everyone. This is Kristen coming to you live for Tutoring Tuesday. And tonight we are going to focus on fact fluency, specifically addition facts through 10, meaning that students by the end of grade 1 should know their fact fluency or all their addition facts up until 20. So we are going to do some strategies tonight that will help you at home to support your students understanding facts. But before we get started, I really want to make sure that you understand what the term fluency really means. I have to be 100% honest with you that when I first started teaching, I thought fluency was automaticity. I thought if I said 5 plus 3, the kids should say 8. 5 plus 4 should be 9. 8 plus 5, hopefully I don't get any of these wrong, 8 plus 5, 13, right? And same thing with multiplication facts. But one thing to keep in mind is that fluency is an accurate and effective strategy to get to the correct solution, okay? So if your students happen to say 8, 9, 10 for 8 plus 2 and they count on, that is fluent. Okay, so they're using a strategy. Now, using their fingers or using counters or pictures is not fluent, and that's okay. But there are stepping stones in order to get there to that fluency part. But I really wanted to make sure that you guys knew the difference between fluency and automaticity. Eventually, students hopefully will be automatic, but there are some students that just don't have that ability to be automatic with facts. I still know a lot of students, even in high school, that don't know their addition facts right off the top of their brain, and I know a lot of you guys will be startled and stunned and probably shocked to know that that's okay because they all have an effective way to get there. For example, if you're adding 8 plus 5, and students know, okay, well, 8 plus 2 is 10, 3 more is 13, done. That's fluent. So we really want to make sure that we know the difference between expecting your kids at home to know facts as soon as you say them, or if it takes them, I would say 3 seconds or less, okay? So if they can reason through the problem and get you an accurate solution using an effective strategy, that is great. Now, when I say effective, I also mean that they're not using these fingers, okay? So just kind of there's a fine line between there. So now what if I told you that all they would have to know is a few small little facts that will enable them to know all of their facts? So what I'm going to do tonight is I'm going to share with you a really fun way to help your students in the classroom if you're a teacher, or even if you are at home working with your students in 1st and 2nd grade, or even if you wanted to work with some of your kindergartners, I'll show you what facts you could start working on. So there are 5 facts that students need to know and be able to do. No question, okay? So that's plus 0. Hopefully that's not a problem. Plus 1. Plus 2, which is easy. They can count on, right? 9 and 2, 9, 11, 11. Doubles. I'm sorry, I keep on looking down. I just want to make sure I don't miss any. Doubles facts are very important. And doubles facts, I would definitely say, is one of those that students should just know. They're easy to what we remember as memorize, but really just know off the top of their head. And it will help with multiplication come 3rd grade. And then the last one, and probably the most important one, is to make a 10. Hands down the most important. So if there's one thing that you're going to work with your kids at home, it is making a 10. Our entire number system is based on 10, right? We're from the base 10 system, right? We have digits 0 to 9, that's 10 digits. And everything builds on each other, right? So we have every place value is built on a group or bundle of 10. And so it's really important for kids to know that right off the gates coming from grade, even kindergarten, but definitely grade 1. So if you're ready, let's get started. So let me flip you guys around. Okay, so what I did was, and please pardon my chicken scratch, but I made it a little addition chart because I figured at home you could do the same thing with your kids. So basically on the top of it, you will notice that there are digits 0 all the way to 10, and on the other side is 0 all the way to 10. And basically what this does is it creates a grid, very much like a multiplication chart, if you will, but it's an addition chart. And so the same thing applies, these two numbers are what fills in that cell, and so on and so forth, okay? And so what I've done is I've kind of highlighted the facts that pretty much students know right off the gates. Now, I've been working with a lot of, let me just stand up here so that you guys can see it. I've been working with a lot of first graders and second graders and some fact fluency cards in our county, and these are the first facts that they need to know and be able to do is at +0. And pretty much, hopefully, your students understand that when you add a quantity of 0, nothing happens to the quantity that you added to. So for example, 1 plus 0, you're adding nothing to 1, so therefore your quantity is the same number, 1. You're doing nothing to that value, you're adding nothing. Now when you have nothing and you add something to it, then therefore that remains the same kind of idea, is that you get that value. So hopefully +0 is not a problem. What you also see highlighted, and actually what I should have done is highlight that 0 plus 0, but that's kind of part of the 0. But on the diagonal of your addition chart, you will notice that these are all of your doubles facts. And remember what I said is that doubles facts are so important for kids to be able to do and know right off the top of their head. So I'll kind of teach you guys something that is really helpful for doubles, but really these are the most important things. So something that you could do at home as easy as rolling a dice, whatever the number rolls on, double it. If you're playing a game, you can do the same thing, either with a spinner or whatever the case may be. All right. So what we're going to do is we're going to kind of focus on these strategies, and I'm going to write them down, or I wrote them down for you. Like I said, the +0, which we just kind of talked about, +1, +2, doubles, and make a 10. And what you're going to notice is that as we work on these strategies, we start filling in this entire chart. And what's really cool about that is that students start seeing success, they start feeling accomplished, and they start using effective strategies to get to some such as like 8 plus 5. That doesn't roll off the tip of kids' tongues, right? 8 plus 5 is just a difficult fact. So they have to use some type of strategy to get to the correct solution. Very much like 9 plus 8. It's close to a double, but not quite there. So we can either use a near double or we can use another strategy. So let's get rocking. All right. So like I said, the few strategies that we're working on, addition facts for fact fluency. Remember what I said is fluency does not mean automaticity. Fluency just means that they have an effective strategy to get to an accurate answer, okay? So +0 we kind of already talked about. The idea here is that nothing changes to the quantity that you're adding 0 to. Or if you have 0 and you add a certain number, then the quantity changes to that amount that you've added. So that's an easy peasy, as we say, lemon squeezy strategy. When we have +1 and +2, what we like to do is we like to encourage you to have your students count on. This is the most effective strategy for kids to know and be able to do. So let me explain. So looking at our chart, you can notice that our +1 strategies go across here, and our +2 strategies go across here, which leaves just these last few facts for us to know. So these are really important for us to remember. So if we're counting on using +1 and +2, let me give you an example. So if you have the quantity of 7 and you add 1, you encourage your kids to make sure that they say 7 in their head and they count one more is 8. Likewise, it's really important when you teach this or when students are practicing it, they see the commutative property. So a lot of kids automatically want to start with the first add-in and add the quantity of 7. But truthfully, the most effective strategy is to start with the largest quantity add-in, so that's 7, and just add one more. So making sure that when we're teaching these two strategies, we are teaching the commutative property of that addition fact. Same thing goes with 7 plus 2. So we encourage students, and something that I do is I have them stick the quantity 7, so 7, and then they put 2 little dots underneath 2. So they say 7, 8, 9, and they put a 9. Likewise, we want to make sure that they see that the same exact strategy can apply here. Make sure that they find 2 plus 7, they can start with 7 and add 2 more, 8 and 9. One thing to kind of keep in mind with that counting on strategy is that when kids first start, it is okay for them to use their fingers, but what makes this strategy effective is that they don't have to start by doing 1, 2, 3, 4, 5, 6, 7 and adding one more. Now, that's how we start teaching them, but when they're really truly learning their facts, we want them to get the quantity of 7 and then just say 8, okay? So we really want to make sure that they understand what counting on and the value of counting on and how that can really support students' understanding. And remember, counting on is a fluent strategy to arrive at the correct solution. So if your students or if your kids at home are saying, if you ask them what's 7 plus 2 and they say 7, 8, 9, then they get that correct because they are fluent and they've solved it within 3 seconds or less, okay? Okay, so now, just by teaching this one strategy, I want to share with you all of the facts that they've now learned. If I can open this, that would be awesome. Okay. So now we've added all the plus ones. And we've added plus 2s. Okay, so now after we've taught them that, we can then go into how we can help our students understand adding by 3. So remember, I told you that if they just learn these simple facts, that can really help them solve other facts that they don't know. So let's take one that's not highlighted with the plus 3. Ready? Let's use 4 plus 3. Now remember, they know how to count on by 2 and 1. So they start understanding that 3 decomposed is 2 and 1. So in their head, they can think 4 plus 2, which they've already mastered, plus 1 more, which they've already mastered, which is the 6 plus 1, will then arrive at the correct solution of 7. So allowing students to decompose these numbers, especially 3, will really help students understand how they can use 2 and 1 to then learn their plus 3s. So now, in every single one of them, every single one of these strategies, when you add 3, you can decompose the 3 into 2 and 1 because now they've mastered how to count on by 1 or 2. So let's try another one. If I have 6 plus 3. So students know that 3 can be decomposed into 2 and 1. And so they can say 6, 2 is 8, and 1 more is 9. You can still encourage students to think about 3 more, but counting on 3 more is a little more challenging. So really utilizing that counting on by plus 1 and plus 2 is really important. Okay, so now that we've done that, knowing how to utilize plus 1 and plus 2 when you're adding 3, we've now accomplished all of these amazing facts over here. Sorry, that's really dark. So now we're left with some facts kind of sporadic. So now let's think about doubles. Now, doubles are just something that students just have to understand and be able to do. But the idea here is that they need to understand that you're taking a quantity such that of 4 plus 4, and you are literally taking 4 and just making another group of 4. So encouraging students to draw these out at first is really helpful, and they start seeing the quantity of 8, or just practicing, like I said, rolling a dice, a number cube, and whatever number that they roll, they have to double it. So practicing doubles is so important. Doubles, I would say, is probably the most important skill or fact that students need to know and be able to do, especially when it comes to, because once they know this, then they know this, right? Oops, sorry, times 2. So they know that the quantity of 4 is now multiplied by 2. So doubles students need to be able to do. And like I said, the easiest way to do that is just practicing. Every time you see a number, you say, okay, what's the double? So you see 3 cars in the parking lot. If it was doubled, how many cars would be in the parking lot? If you are going to the grocery store and you have 4 bags and you told your kiddo, if I doubled the amount of bags, how many would I have, and have them solve that. And the more and more they are exposed to this, the more and more they feel fluent with that. And like I said, these are already highlighted on the diagonal, the double facts. So now we get to the making 10 strategy. Are you guys ready? So why is making 10 so important? Well, I'm going to tell you that making 10 is I would say, the most important strategy, along with doubles, that students need to know and be able to do, hands down, okay? So something as easy as a number cube, roll it, and say, make a 10. So if I roll a 2, what would I have to add to that to make a 10? Simple, simple, simple. But the more that they're exposed to that, the easier it is. So the best thing to do for make a 10 is to take an egg carton and get 10 little little compartments, and then just practice. So you can even get M&Ms, and you can put 3 down, or counters at school, and you can say how many more to make a 10, and they can see that it's 5 on the bottom, 2 more is 7. Okay, so I would say that these, making a 10, they need to know completely 100% through practice, through using strategies, through using hands-on exploration. Now let me share with you how these 2 strategies can support students knowing facts such as 7 plus 6. So oftentimes what I see is students are drawing 7 or drawing 6 more and then adding them together, which is it's not bad. It's just not where we need them to be in the fluency stage. I see a lot of kids that start at 7 and then draw 6 and then count on, which is not a bad strategy. But like I say, counting on really is effective with +1, +2. But when you get to 6, it's not as effective. And remember, we want fluency, which is an effective strategy to produce an accurate answer. And as soon as numbers become greater than 1 and 2, we lose count. All right, so if I'm adding 6 to the quantity of 7 and I know how to make a 10, I think of what's in the 6 to make a 10, and I decompose it. I know 7 and 3 make a 10, and 3 more is 13. This strategy right here will allow students to start decomposing, thinking flexibly, and will help when they have to go into the regrouping phase of addition when they have multi-digit numbers to add. They know that 7 and 6 is more than 10 because 7 and 3 makes a 10 and 3 more makes 13. So let me share with you another one. 4 plus 8. So students can easily decompose the 4, they can decompose the 8, however they want, but the most effective strategy would be to take the largest quantity and remember making that 10. So 8 and 2 makes 10. So 8 plus 2 is 10, and 2 more is 12. So really encouraging students to see numbers flexibly and see how 10 lives within 8 and 4. And a lot of people, I hear a lot of, opinions about this strategy and the fact that, why would I make a 10? Well, in your response, you have a 10, right? So technically, you're still making a 10 no matter how you do this. So you might as well teach an effective strategy for kids to see that 10 lives here in order for them to arrive at the fact that the solution is greater than 10, and in fact, it's 2 more than 10, which is 12. So let's do another one, 6 plus 9. So we all know that we can decompose 9 and make a 10 this way, or we can make a 10 this way. It doesn't matter how you do it. I'm going to start with 9 and decompose that, but you could do anything you want. So I am going to think about what quantity added to 6 will give me a 10, which is 4. And I know 4 and 5 makes 9. So 6 plus 4 and 5 more is 15. Likewise, I could do 9 plus 1 and 5 more is 15, and they equal the same. So getting students flexible and comfortable with numbers is really, really, really important. This last column, adding 10 to a quantity, is very similar to just adding a 0, right? So you're utilizing 4 plus 0, but you know you also have one 10. So if I have a 10 and I have no 1s here, but I'm adding 4 more 1s, my 1s are impacted. So here we go. So now that we've talked about these strategies of how we can solve these problems using these effective strategies, let me share with you. These are all the 10, make a 10 strategy. So 4 plus 6 makes a 10. 6 plus 4 makes a 10. We already did 7 plus 3. We already did 5 and 5, which is a double. We already did 8 and 2. Oh, we already did 9 and 1. We already did 10 and 0. Go figure. So students already know by now how to make a 10. It's just a matter of now applying that to various strategies, okay? So there are a few strategies that don't work, and these are the two right here. And I'm going to share with you why. You can't make a 10 with these two facts. You can decompose 4 because 5 and 5 makes 10. And you can't decompose 5 because 6 and 4 makes 10. So these are the two leftover strategies that students cannot either use a double, make a 10, but what they can do is they can add on, or they can think about adding a double. So if I'm trying to solve 5 and 4, I know 5 and 5 is 10 and 1 less is 9. So these are the outliers. But that means that really, when it comes down to it, if students really just focus and narrow their vision on these 3, 4 strategies, that only leaves 2 remaining facts for them to really learn. How cool is that? All right, so let me flip this guy around. All right, so hopefully that was helpful for you guys, but I do know that when I'm either at schools and I'm talking to some friends, they're always talking about their kids just not knowing their facts, and they just need strategies and they need some support at home. So I thought that this would be a nice, just brief refresher of how simple it really is, and how really learning these facts isn't about, that automaticity, right? Needing to know it right off the top of your head, but really utilizing what they know and how they're reasoning through the problem is really crucial. The more students know something using a strategy as opposed to just memorization, it's very important. So that's why when you're learning the doubles, just making sure that you're encouraging them to know that a quantity of 5, using your fingers, and 5 is 10, very similar to just thinking about how many fingers and toes you have, right? So that's it for tonight. Hopefully that was very helpful in thinking about how to help your kids and support them at home. And then if you are a classroom teacher, just how to narrow your vision on understanding and learning facts. Now, one thing to kind of keep in mind is that when you are thinking about that +1, +2, you're doing the commutative property. And when you are learning doubles, just practicing and seeing doubles everywhere we are. So you would be surprised if you looked around where you are, whether that be in your kitchen like myself, or a living room, or even a bathroom next time you're in there. looking at all the examples of double throughout the world is just truly important. So even thinking about your car, you've got 2 wheels on this side, how many wheels on this side, so how many total wheels? How do you know that? 2 and 2 makes 4. And just thinking about just different opportunities for kids to see. Making connections between animals that have certain number of legs on one side and certain number of legs on the other is important. So spiders, if your kids like creepy crawly stuff, I'm not a big fan, but if you like creepy crawly stuff, thinking about spiders and thinking about legs on one side and legs on the other. So I'm going to put something in the comments to help you guys with doubles and just kind of thinking about how to bring in real world examples of doubles, and hopefully that's helpful. All right, remember, math is fun, math is great, math is beautiful. Have a great night, guys. Take care. Bye-bye.